Hey everyone, welcome back. We're going to talk about parts of similar triangles. So this is going to be in section 7.5. So there's a few things that we need to review before we go ahead and get started. And that is three basic vocab words. The first one is going to be our altitude. So altitude, remember altitude looks like this. Let me draw a triangle in here. Okay, so here's our triangle, and altitude would be a segment that goes from an angle straight down, and it makes a 90-degree angle. Okay. Our other word that we want to look at is our angle bisectors. So angle bisector, and an angle bisector might look something like this. Triangle, and then we have an angle bisector here, and it splits the two angles in half, okay, so that they're congruent. And then our third one we want to review is our median, which people tend to get mixed up with altitude a little bit. If we have a triangle for our median, then it's going to go from one side to the midpoint of the other. So in this case, the only thing we could tell is that those two segments would be congruent because it splits it in half. Nothing else is necessarily congruent. So these three vocab words you've all seen before. We learned them last semester. We're going to start talking about them again. We're going to use these in terms of our proportions with our triangles. So let's look at our basically three theorems that we have today. So the first one is about our similar triangles and altitudes. And this first one, so in the book it's theorem 7.8. I don't really care what you call it in your notes, but the rule says if you have two triangles that are similar, okay, so I'm just going to draw two triangles, it doesn't matter what size, and then I've got altitudes drawn in. So here's one altitude, here's the other, and we know they're altitudes because they make 90-degree angles. Let's call this triangle AC. The point here is D and B, and then this one we'll call F, H, J, and G. So this says if the triangles are similar, the lengths of the altitudes are proportional to the sides. So in other words, the basic way to put this is if we say triangle ACB is similar to triangle FHG, if they tell us that's true, then we can write that AD, that's our one segment, our altitude of the first triangle, and then FJ, that's the altitude of the second triangle, would be equal to our ratio of one of our side lengths of the triangle, maybe AB over FG. And it doesn't have to be those two sides, it could be any two sides, but the ratio would have to be the same as the ratio of the altitudes. All right? So let's look at an example using this concept. Let's say we have triangle. There's one triangle. Here's the other. Draw our altitudes in. Yes, you're going to have to draw a lot of triangles. Sorry about you. And let's say we have M, K, P, L, and then Y, X, Q, Z. And we've got this is congruent with this, and this is congruent with this, and we have that this is X, and this is 15, this height is 16, and this one is 20. Okay, so this is example 1. So we want to go ahead and solve for little x for the altitude YQ based on the information that's given. Well, they tell us that this is going to be similar triangles. Okay, and so we can go ahead and set up our proportions. So side 20, LM, This matches up with 15, so we can say 20 over 15 has to be congruent to our altitude heights, so 16 over x. So 16 over x, and then of course we can cross multiply, so we would get 20x equals, and then of course you could multiply 16 times 15, which gets you 240. Divide both sides by 20, and you get the x is 12. Now obviously I don't have this drawn to scale, so that triangle looks bigger when it really isn't, and that's okay. As long as you can set up the proportion and solve, then you should be good to go. The same rule applies excuse me, for our angle bisectors. So if we have two triangles here, there's one, here's the other. If I call this KLM and this is QRS, and we have angle bisectors drawn in, and pretend these look like angle bisectors, and we'd mark them, of course. Here's one angle bisector, here's another angle bisector, maybe we call this T and P. Okay, so if these two triangles are similar, so triangle KLM is similar to triangle QRS, then we can say that our side, or our angle bisectors, so LP over RT, both the angle bisectors have to be proportional to one of our side lengths. So maybe I say LM over RS. Okay, it could have been LK over R cubed, just depends on what they give you. As long as it's the proportion of the angle bisectors is equal to the proportion of two sides. So in your book, this is theorem 7.9, and this is with angle bisectors. So same rule applies. So in this type of problem, I'm just going to throw in an example here. If I would tell you that let's see, this side is 15 and this altitude is angle bisector is x, and then this side is 12 and this is 8, we could set up a proportion, so this will be example 2, that 15 over 12 has to be equal to x over 8. And of course it's always a good idea if you can reduce your fractions to try to do that as well. So I can reduce this, both go in, 3 goes into both, so we get 5/4 equals x over 8. So we get 40 equals 4x, so x equals 10. I need to be done. And then last but not least, the same theorem applies to our medians. So you got to be really careful with your medians that you don't confuse it with our other two. So here we've got a median, we'll call this x, y, z, and then A is in the middle, and then we've got another median drawn. We'll call this QRS, and we'll call the middle one B. So if we said that triangle XYZ is similar to triangle QRS, then in this case, oops, and I should mark this, these are mid-segment, or our medians, then that means for this problem that our segments of two sides, maybe XY over RQ, would have to be proportional to our medians, so AY over BR. Okay, so this is theorem 7.10, oops, and that is with medians. So same concept. So in this type of problem, if I give you that one median is 13.5 and this is x, and then the other median is 9 and this is 3, okay, not drawn to scale, you could set up your proportion. So 13.5 over 9 would go with x over 3, and then we could go ahead and multiply. So 13.5 times 3, that gets you 40.5 equals 9x. Divide by 9, you get x equals 4.5. And of course, if you have units on it, please make sure you include those as well. And really, that's the majority of this section. So you want to be careful. Oh, there's one last thing, triangle angle bisector theorem. This one's very similar. Still, we're dealing with proportions, but different sides of a triangle. Okay, so let's say we got a triangle here, and we've got an angle bisector. Okay, so that this is the same as this. Let's call it JK L, and then the middle point here is M. So this says if an angle bisector in a triangle separates the opposite side into two segments that are proportional to the lengths of the other two sides. Okay, so for example, if segment JM, KM, sorry, KM is an angle bisector, okay, then we can say that, let's see, ML over JM, okay, so I'm talking about this side and then this side, okay, so this is the proportion here, would have to be proportional to LK over JK. So it would have to be proportional to this side and that side. Okay, so the two base parts here would have to be proportional to the other two sides. So let's look at an example where this would apply. Let's see. All right, so let's go through an example with this one. An example here, we have two sides, 11 and 14. We have an angle bisector obviously drawn in because we have the two congruent angles, and then they tell us that the whole bottom is 20, and then this part right here is x. So all we have to do to solve this is set up a proportion. And we don't have the length of the angle bisector. That's why we're not using an angle or using the proportions like we set up in the last examples. So if we want to set up a proportion here, we take up the proportion of the sides, so 11 over 14, and then we would do this side here over this side here. Well, we know x is going to go on the bottom because that's the right side with the 14, but over here we don't know what this length is. We just know it's part of 20. Well, if we know the whole thing is 20 and this is x, then we can just call this 20 minus x, just subtracting it. So 20 minus x goes right there. And so now we can go ahead and start multiplying by cross multiplying. So 20 times 14, that's going to get us 280. So 280 minus 14x equals 11x. So 280 equals 25x because I just added 14x over. And divide both sides by 25. And we get that x is equal to 11.2. So this would be this missing side length. And you'd be done. Okay, so remember, left side goes with left side, right side goes with right side, and we set up the proportion. If you have any questions, please feel free to let me know. Otherwise, you guys are good to start the book assignment, and you guys should be good. Thanks for listening.